Okay, an experiment is any process that generates one or more observable outcomes. The sample space is the set of all possible outcomes. Okay, so suppose you have the following experiments. List the sample space. So number one is flipping a coin. So what different outcomes could you have? Heads or tails. So my sample space, which we usually call S, my sample space, that keeps happening. Is heads, comma, tails. You could have either of those. We usually do the little braces that you guys hate drawing. Okay, rolling a die, what would the sample space be for that? 1, 2, 3, 4, 5, or 6. Counting the number of stars in the sky. Yeah, you could have 1 star in the sky, 2, 3, and it goes on forever. Dr. Vesper walked in one time when we were talking about that, and he had a nice argument for it. If there was an infinite number or a finite number. I don't know, you'll have to ask him. Okay, events. Any outcome or set of outcomes in the sample space. So for that first part A, I could have an event is rolling a heads. Or not rolling, flipping a heads. I could have rolling a 4 and then a 5. Okay, so it says above we have the experiment rolling a die. The set 2, 4, 6 is an event. It's rolling a 2, 4, or a 6, or rolling an even number. So probability of an event, this is a number from 0 to 1. That's very important. When you guys talk about probability, it's always between 0 and 1. So you're not going to say 50%, you're going to say 0.5, right? It indicates how likely the event is to occur. So if something had a probability of 0, what does that mean? It's not happening, right? If something had a probability of 1, it means it's definitely going to happen. Okay, so suppose a box contains 50 candies. 20 are strawberry, 15 are grape, 10 are lemon, and 5 are orange. An experiment consists of drawing 1 candy from the box and observing its flavor. So what is the sample space of the experiment? What are the possibilities you could have? So when you look at the color, you could have, or not the color, but the flavor, I guess, strawberry, grape, lemon, or orange. So those are your different outcomes. Then it says, what do you think the probability is for each color? So your probability of getting a strawberry, what is that? 20 over 50, which is 2/5, right? Your probability of getting a grape, you could also write out the word grape, you don't have to do G. Probability of getting grape is 15 out of 50. Divide both by 5, you get 3 out of 10. The probability of getting a lemon is 10 out of 50, which is 1/5. And the probability of getting an orange is 5 out of 50. Which is 1/10. Okay, what if I asked for the probability that a strawberry or orange candy will be drawn? You add them together, right? So the probability of strawberry or orange would be, there were 20 strawberry, there were 5 orange, so 25 out of 50. So it's 1/2, or you could say 0.5. So these numbers are all between 0 and 1. Okay, today in our SAT question of the day, we use what we call the complement. So the complement of an event is the set of all outcomes in the sample space that are not included in the outcome of event A. So remember when we were talking about the people standing next to each other, we said, how many ways can we rearrange these 4 people so that they don't stand next to each other? So we found all the ways that they could stand next to each other. So you find the opposite, and then subtract them out. Okay, so number 1, it says a single card is chosen from a standard deck of 52 playing cards. What is the probability that it is not a king? What is the probability that it is not a face card? Okay, so how many kings are there in one deck of cards? 4, good. Some people don't know decks of cards, so I won't ask these on the test. But so there's 4 that would be a king. So how many? So if I found the probability of not king, that's going to be 1 minus the probability of getting a king. So 1 minus the probability of getting a king. There were 4 cards out of 52. So that's 1 minus 1 over 13, which is 12 over 13. Now you could just as easily use the complement with not it being a probability, but you could say, what's the opposite of getting a king? All the other cards. So 52 minus 4 would be 48, right? So there'd be 48 cards out of 52. And that will also give you 12 out of 13. So you don't always have to do 1 minus. Okay, what's the probability of not getting a face card? So how many face cards do we have? We have jacks, queens, and kings, right?
12.
There's 4 of each, so there's 12 face cards. So we want to do 1 minus the probability of getting a face card, which is 1 minus 12 out of 52. So 12 out of 52, and I do 1 minus it. I'm going to change it to a fraction. I got 10 out of 13. So 10 out of 13. Okay, 2 dice are rolled. What is the probability that you get a sum greater than or equal to 4? Okay, you could look back at your chart and you could count all those different things. What's the complement of this event, though? Less than 4, right? So complement is less than 4. So how many different ways could I get less than 4? I could have a 1 and a 1. I could have a 1 and a 2. Or I could have a 2 and a 1. Those are the only things that are less than 4 with 2 dice. So how many total ways were there? Do you guys remember?
36.
There's 36 total possibilities from that chart we've drawn before. So we have 3 out of 36 ways to get less than 4. So my probability of greater than or equal to 4, I'll write it as sum is greater than or equal to 4. I have an extra swoop in there. Is 1 minus the probability that the sum is less than 4. So is 1 minus 3 out of 36. So you get 33 over 36. How does that reduce? 11 over 12. They're both divisible by 3, right? Okay. Good so far? I think probability is a lot easier than the counting principles. Okay, odds. Okay, the odds that an event will occur can be expressed as the ratio of the number of ways it can succeed to the number of ways that it can fail. Okay, this is really important because when you go to like Las Vegas or a horse track or something like that, they're giving you the odds. So they're saying something like 3 to 4. And you're thinking, wow, this horse is going to win. It has a 3/4 chance of winning. That's 75% chance. But that's not what that means. So if it's the number of ways it can succeed to the number of ways it can fail, that's really 3 ways out of 7 total. Did you guys see that? So that's not good. So see how like casinos and horse tracks, they kind of trick you. They make you think your probability is really good, but it's not really. So 3 out of 7 is not good. Okay. So it says if the odds, oh, I just gave this to you. If the odds of winning in a casino is 3 to 4, what's the probability? So there's 3 ways to win. There's 4 ways to lose. How many total ways to do anything are there? 7. So your probability is 3 out of 7. So why do they use odds instead of probability? Because most of the time it looks a lot better. It looks like you're going to do better than you really are. No, it's well known that they use odds, so you can't sue them. Okay, number 2. According to the U.S. National Center for Health Statistics, the chances of a male born in 1990 living to at least 65 years of age is about 3 in 4. For females, it's about 17 in 20. Okay, so what are the odds of a male living to be at least 65? So your probability was 3 to 4. So how many ways to live versus how many ways to die? It's kind of morbid. So 3, 2, 1. That's your odds. Do you see that? So your numbers added together make the denominator of your probability.
How would it be the same as the one above?
Okay, this is the opposite. We're going the opposite direction. So this is the number of ways to win. This is the number of ways to lose, which is kind of true, I guess. What?
I don't get why it's not 3 7.
Okay, go backwards. So if I was starting with 3 to 1 odds like I was up here, so 3 to 4, it'd be 3 out of, add them together, 4, right? That's your probability. So it's the opposite question. They're backwards. No, you cannot write it as a fraction. Odds are always with the colon. No, it's 3 to 1. Okay, what are the odds of a female living to be at least 65? So there were 20 total ways. How many ways to win? How many ways to lose? Think of it as winning and losing. So it's 17, right? 2, 3. 17 to 3 odds. Okay, out of those 20 people, how many died, Isabella? Isabella?
Yeah.
You get it? Okay. Out of the 17 people, 3 people died, 17 people lived, winning to losing, 17 to 3. So the odds of living is 17 live, 3 die. Okay, find the odds of each outcome if a computer randomly chooses a letter in the word Alabama. So let's say we're doing A to, I don't know, B to M to L. Oh, well, no, that's not what I'm trying to say. Never mind. So the odds of each outcome. So for the odds of an A, odds of A. How many ways will I successfully choose the letter A? 4. How many ways will I not successfully choose A? 3. There's 3 letters left, right? 4 to 3. Odds of L.
1 to 6.
Yep. Odds of B.
1 to 6.
Odds of M. 1 to 6. Okay, if I asked for each of those probabilities, what would be the probability of getting an A?
4 to 7.
4 out of 7. What would be the odds of L, or the probability of L? 1 out of 7, right? Total possibilities. 1 out of 7 for the rest of them. Okay.